Hello? Hello? Now? Yeah. So let's get started. Uh, so we've been going through, many of us have been through at least one, if not more, technology waves. But this coming wave, arguably the wave we are riding now, AI and robotics wave, the fourth wave, is a different one. So it's different in the sense that the question about what is after this wave, it hasn't occurred to us yet. So we are in the beginnings of the wave, and the expectation is, not expectation, but anticipation. Where is this wave is going to connect to? So intelligence. So what is after intelligence? So it's a little bit problem, but as you see, we see this wave growing and growing. So it's a different one than the first three ones we have experienced. So, without reading the tea leaves, let's see how we got here. So Internet of Things fueled much of the industrial internet. So the data comes through the edge, through the cloud, and it's a huge volume of data coming from everywhere, from the edge into the cloud. So it's not only the data anymore. So, and today in the morning, opening the session with Abe, sorry, I call him Abe-san, the Japanese pronunciation. So Abe described this new business intelligence. So now the data turns into information, and the embedded analytics, as soon as we obtain the data, so the embedded analytics is the new norm. So as soon as we obtain the data, so dealing with the data as fresh as possible. So there is some time aspect to it, and in in-memory computing, we are addressing that, dealing with the fresh data as soon as possible and getting insights. And I like to open it up here, insights, quick insights, and also meaningful insights. So imagine into a store, somebody walks in, and that somebody has bought $1 million electric car in the last week. So if I quickly give an offer to this person about morning donuts, okay, I acted quickly, in memory this, that, I gave him an offer, which is good, but is this the right offer? Have we missed an opportunity? So is it the best offer we can make? We did give one offer, but is it the best offer? So the business people usually say, I'm hearing the business people rather than IT people, well, telling their IT people, why don't you take a little bit more time, spend a few more milliseconds and give me a best offer, you know? So this is a high value customer. He spent $1 million with us. He has good credit. Hamburger offer or donut offer is not the best. So we have to leverage that. Take your time and give me a best offer. So business needs insights now, but actionable and meaningful insights as soon as the data is obtained. So in-memory computing, so we come to the, from here we see a good lead into silicon and hardware. So it matters how fast we do things, and also it matters how deep we can go into our analysis and extract the data. So the data accesses, that's why we are doing in-memory computing, accessing data in memory speed. And now to extract the meaning, we are using GPUs, FPGAs, as well as CPUs. So at this phase in the wave, silicon is making an entry back into Silicon Valley, as we say. So what silicon and how effectively you use these hardware resources is going to make a difference. So we have terascale problems. We like to achieve high performance and scalability. So cognitive computing is coming. And what is a good way to intercept all these and fuel all these developments with good hardware? So let's open a window into our silicon challenges. So Fujitsu, we have good and strong background in hardware platforms, in processor design, and silicon operations in general. So there is a challenge here to go high in performance and to go low in power. For deep learning, truly, we need to achieve orders of magnitudes improvements from where we are, even with the state of the art. Now, we have to go orders of magnitude higher or further on the performance per power consumption for deep learning, for meaningful deep learning, to make a difference, to help us ride that wave further. So conflicting demands. Nobody wants low performance. We want higher and higher and higher performance, but the power envelope, we have to be cognizant of that. So the challenge from a hardware or silicon point of view is to find that combination. So to get high performance, yes, we do high performance computing, HPC systems, and we are familiar with the requirements of that. We squeeze as many transistors as possible. We use out-of-order, state-of-the-art implementations. We put together many execution units. We do single instruction, multiple data implementation vector units, and we go higher and higher clock frequency. So the reality check over there is the Moore's law. So within Moore's law, how far we can go. So in the low power side of it, we can, so that low power requires using more modest number of transistors and to do with simpler logic, control logic, and perhaps fewer execution units, and stay with the lower frequency. So apparently they are very, very significant trade-offs. So what we discussed so far is general purpose computing. So that we have to live within the bounds of Moore's law. So to break that, envelope, basically we have to think differently. So in supercomputing domain, so we are scaling with high performance. But for deep learning, to do inference on one side, and through deep learning, supervised or unsupervised deep learning on the other side, we have to break that trajectory. So that brain computing will come, and we also discuss is quantum computing. So it's our all efforts to break that trajectory. So limits of Moore's law, we have to go outside of it. So in Fujitsu, we see that this trilogy of technologies coming together to provide a good path. On HPC side, in next month we will be in Denver showcasing some of our high-performance computing technologies. So for simulation and pre-processing, that's the domain. In quantum computing, very, very interesting. Combinatorial optimization problems are being solved, so that's also established a very good technology corner. So in deep learning, with high-speed learning environment, we like to provide. So we see all these three directions, one from quantum computing, the quantum leaps to be provided, high performance computing, so taking that to the limit, and bringing that with deep learning. So these three technology directions are accelerating the position in the wave. So we have a new architectural approach taking us outside the Moore's law, taking us from conventional architectures into new architectures. So first of all, there's nothing wrong with the conventional architecture for the workloads they have served, and it has served us so well. It has served the industry so well. So this is in the conventional architecture, we have general use, complicated, out-of-order cores, getting more sophisticated and more sophisticated, we can make them. High precision, so that's interesting, the single or double precision representation, and then the operations with that. So in the simulations or in the database operations and this, that, so that is being utilized. And those are the things that we can relax and to get into a new architecture for a specific purpose. So in the new architecture, we are thinking deep learning workloads. So domain-specific cores. So we don't have to, so it's not good for every workload in a general direction, but for the deep learning. So if you want to extract meaning, so you have all the data, and now you have to create a model. So for that workload. So to do the optimization problem, to find that model that you can use in inference mode on the edge. So, so do we need all the high precision? So we can relax that. So adjustable precision or low precision can be used in a huge optimization problem in lieu of getting to the optimized state, to finding the optimized state, to find the global minimum. So if you are working with 64-bit or higher bit precision numbers, basically you are given a very fine tool to find the feature in the big haystack. So that you can do with a little bit bigger numbers. So use the optimal precision and still don't lose the precision of the final solution. So it is an optimal, and it makes a huge difference in terms of power required and also in terms of convergence characteristics. And one of them will not be enough ever. So we are hearing many times over in this conference. The technology needs to be scalable, so we can scale on-chip with an on-chip network and many of these chips are connected in an high-speed network together. So that becomes we have in May and later in May we announced a deep learning unit, our AI chip technology. So that's basically the crux of it. And if there are any questions, I'd like to meet you. We have a small booth over there, or you can fire up a few over here. So, any questions from the audience so far? Please.
Are you also doing the memory-centric computing?
Memory-centric computing, in the last in-memory computing summit, I introduced a large memory platform. We can go up to 32 terabytes of memory, 384 compute cores, so I can provide a sea of memory in a single system image. Yes, the answer is yes, yeah. So the memory, yeah. But here, so this DLU don't replace any workload with and you try to use DLU. So if you have a combinatorial optimization problem, if you are doing like financial services, portfolio optimization, or finding cancerous cells in the body or the behavior, so big optimization problems, so that's what we are going after for this DLU. And if I can oversimplify it, so at the end of it, the math is still the same. And you have like heavy matrix multiplies, doing singular value decomposition, other things. So that's what we want to catch here. Other questions? So it's exciting times. I'm not giving the timeline for it yet, but it's a technology we have announced and we have showcased in exhibitions and industry meetings so far. So please stay tuned. So, so the way we work at Fujitsu to work with partners. So not only a hardware solution, but we develop the ecosystem with both big data companies or partners, analytics partners, streaming analytics partners, as well as IoT and other areas. So we like to work with you guys, users on one side, and the partners on the other side to enable and to provide, to build an ecosystem together in these technology directions together. So, as an example of this, our approach, so I like to talk to you about a solution we have built with Systriim, another sponsor of the event here. You can visit them, and in the morning we had a session with Steve. So with their streaming analytics solution. So we combine that software together with our existing general purpose compute and big, large memory platform to do a very innovative solution. So the solution is in the cybersecurity space. So everything is connected and everything is automated. In a factory, every process is automated and everything is like a small computer or big computer. So that's an alert, actually. So it means everything is like they can be hacked. Everything, the door opener, the centrifuge controller, process controllers, it can be, they are exposed to hacks. And then we hear it in the different news that things happen. So the more connected, so that's the challenge. The more connected these things are, the more easier for these intrusions to spread. So once in, it does spread quite fast. So what do we do? So we have to capture these attacks as soon as possible, prevent them in the first place, and capture them as quickly as possible so the damage is limited and the intrusion is contained in a way without spreading further and further. So in this cases, it can be sophisticated attacks. So equipment such as robot, let's say it's been compromised, and in the firmware there is something that got there, and so let's say we are monitoring. Well, no surprise, the monitoring reports everything as normal as it could be, because the firmware is compromised, so it's reporting good health messages. So if we are satisfied with that, we will be in trouble. So let's collect more data. Let's not count on a single source of firmware reporting good health. Let's get good health reports from all other directions, or many other directions. There is a position camera, there is a vibration sensor, there is a logs, entry logs, there is a temperature, and there is operations of the other equipment, and there is physical checks, perimeter control, VPN logs, firewalls. So the data is coming from everywhere, and it's coming continuously. So one thing it says normal, but then we like to obtain reports or data from other instruments. So that's so direction is over-instrumented. So obtain data from wherever we can. Collect all the data and, well, all the data. Let's use all the data, let's analyze it, let's correlate. Let's see if there is an anomaly in the combination of these. So in the single instance or single data source, it's saying it's okay. It's not even an anomaly, it's not even a, it is giving good health. But in combination with the other things, we should make more sense. So to cope with that data, even with simplified or small number of data, the security analysts, they are having a field day. They are getting literally millions of notices and alerts and using over-instrumentation and getting more data. The job is hopeless, so that's the case for machine learning. And then let's use the best technology available to analyze this and get there. So the scary example is the Stuxnet. So the centrifuge is compromised, it's running out of balance, it's speeding up and it's going faster and faster, and if you look at the dashboards, everything is green. So let's get more data from other resources, and then let's build the confidence. So they cannot, so there is never 100% confidence, but having hundreds of sensor data analyzed, and let's try to detect these things even before it happens, when it is in formation. So that's the direction we like to move. So the correlation is the name of the game. It's the deep analytics, if you will. So we can look at scan the port, see an activity there. Maybe by itself it doesn't mean much. It's just an irregularity, some down access point or something. There is a port scan is happening. There is a translation, and okay, there is a bad guy downloading some updates. Okay, people download updates any time of the day, but now the things are lining up for a perfect storm or perfect intrusion. Yeah. So let's detect that and let's report that. And then the security analyst, instead of looking at a million things, okay, if he gets a fraction of these, he will be happy to act on it. So the partner here, Systriim, it was covered in the morning session, and you can visit them and Fujitsu in the demo or the booth section too. So they are the ideal partner for us. So getting data, assembling all the data from different data sources into different data targets, and everything is in memory without touching the committing or without persisting into any storage. So data in flight, and then we can analyze the data flying through, and then we can do alerts and other insights while the data is flying through. So we develop streaming dashboards to see this security analytics, and please come by to see the demo videos. If you have time, I'll play it at the end a little bit. So one intrusion is detected, and the other one is detected and marked, and then the action is recommended. So the story doesn't end here. So far, knowing the rules, or we develop more complex and more complex rules, but at the end, so that's the, so what are the rules? And then so the attacks are happening, new attacks are happening, and then we like to have a system that is acting on the edge or collecting the data and acting on the edge, but it is also connected to the deep learning so that it learns while things are happening. So when the new attacks happen from different directions and in different nature, we can bring a resolution to that the same way. So with Systriim, they have an intelligent data integration platform. So that's the little bit philosophical part. So with limited memory, limited resources, as simple mortals, knowing the rules, and getting the limited data, exposing the external data, living the daily life. So we can act in our own capacity. Capacity here, the compute and storage and memory. So given that, we can do things locally on the edge. But the big wisdom is up in the clouds. So when we see something, so within the given boundary, we are comfortable living our lives and handling the exceptions and alerts, this, that. But when a new thing happens, well, we have to say that, well, I need a new rule, or this is what happened. I'm starting to deviate too much from my model. So it continues learning. So we have to still look up to the clouds, and in this case, literally or otherwise, and then get new wisdom, knowing our capacities and our limitations. The cloud issues new things to us. And perhaps our limitations are a little bit needs to be developed, and it gives a recommendation. So that's a complete intelligence platform, and that's where we need our deep learning in the cloud to facilitate this interaction. Fresh data comes in and connected with the deep learning to generate new models or train to do the continuous training too. So the exciting things here is that so the training or learning does not have to be in the clouds. So we like within the given capacity and the resources, we like to push that intelligence collection and training to whatever scale. As for the use cases, and cybersecurity is one of those, to push it as close to the edge as possible. So that's interesting. So the training, so this is complementing APES and the in-memory computing conferences vision. So business intelligence, now we have a consolidated platform, the transactions and analytics are happening here. So I'm developing that. Learning is also happening on the edge. So that's the vision, and we are unfolding or acting on our vision quite quickly. As you see, we have a deep learning architecture. We are bringing that to fruition, to the realism in the coming. So we will be, we are doing beta and other programs with that. So machine learning, building the models in the cloud, and then bringing the models to the edge. Inference happens on the edge with the wisdom from the cloud, but do it in real time in a combined way. So that's the direction, like the training in the cloud and training as the data is flowing through. So that's not too far from it. And so and last week I was in Las Vegas. Not that I lost money, but we were with McAfee Cybersecurity Summit, and there is no other way for cybersecurity. There is no way manual labor can keep up with it, and automation is something we realize now, but also intelligence and deep learning, AI and deep learning, they have to bring it to the technology. So, and then they are cybersecurity. We need our best technologies. If it is GPU today, GPU. If it is deep learning tomorrow, yes. Quantum computing, when it's due time at the tolerable coldness of temperatures, yes, we'll use the best. So intrusions. So it's so keeping ahead of the intruder, no? So this is made it into a easily deployable solution that is connected. Stream software running on a large memory platform for this solution. And for this solution and other solutions, we like to partner with all the technology companies to advance the state-of-the-art together. So that's all I have, and I think we have little time, so let me just play this. Let me play this video if I could, and then receive the questions.
Critical reliability for high performance in-memory computing. This virtually unlimited data processing capability enables true real-time analysis, forecasting, and decision-making. With IoT Edge Analytics from Systriim running on Fujitsu M12 servers, manufacturing companies can outsmart cyber attacks, prevent major losses and disruption to business, and deliver a more proactive defense against both known and unknown security threats. Talk to us today to learn more about the Systriim Fujitsu cybersecurity appliance for proactive defense against security threats. Introducing the Systriim Fujitsu Cybersecurity Appliance, the only cybersecurity appliance for proactive defense against security threats. Systriim and Fujitsu are partnering to bring an advanced security appliance for manufacturing companies using IoT Edge Analytics. IoT promises to dramatically boost the digital transformation in the manufacturing space, helping create the digital factory. Unfortunately, this digital environment makes it easier for hackers to affect machinery settings and hide the changes they caused. The intrusions can remain undetected.
Yeah, let's see. So, any questions? We have quite a few minutes for the, please?
Let me ask you
Please,
a rather tactless question.
as tactless as you can be, please. Yeah,
Would the same technology,
yeah, be available to hackers.
same
Yeah,
help the attackers as well?
yeah.
You get into an arm race.
Yeah, exactly. And that was the term we use in the cybersecurity summit. Is it an arm race? So the one key over there, so we can provide the platform, we can provide the software, we can do the deep analytics capabilities. But what is there is whoever has the most data, I think they have the upper hand. Generally, in optimization problems, that's the case. You can have the sophisticated model, mathematicians doing that, this, that, but the next guy, I have 10 times as much. Even with a simple model, I'm going to do more harm or I'm going to do more good, depending on the intention. So whoever, I think that's one, it didn't come out in the cybersecurity summit as much, but whoever has the most data, even with lesser resources, that guy will be effective, whatever he chooses to be. That's one thing, and also it is an arm race, yeah? So, and these are all sensitive security, in security area, but also in an opportunistic, like retail things too. So today you saw that in Cyberbank. Yeah, they have the largest memory AI cluster. I don't, maybe I shouldn't call it AI cluster, but largest cluster, even compared with the top 500 machines, the memory footprint, 1,236 terabyte footprint, which is 10 times larger than the closest next scientific machine or Alibaba machine.
With many of these analytics-based anomaly detectors, they have to learn
Yeah.
what represents the normative state. How long does it take for Systriim to learn a factory application to determine what's normative?
So that's the part we are dropping the deep learning unit. So it has to happen fast, in a reasonable time, not a matter of days, and attacks as they are happening, perhaps, to close that window. So I don't know the state of the art, but I guess it depends on the, but that we want to get performance per power metric is important, because the more we think, you also do these things within the power envelope. So I use up 1 megawatt power to do this analytics, and if I can do 10x improvement on that, I can go a lot more.
In your customers who are using this solution today?
So we are talking to the initial prospects, so in the fraud detection area, so that's in financial services, similar idea, anomaly detection, or opportunity detection, depends if you are looking into positive or negative outcomes, and cyber security with the manufacturing. Manufacturing for two reasons. One reason, manufacturing people want to see edge solutions, as opposed to cloud-based solutions, because that millisecond at the best, even with 5G, that connectivity cost, they're not going to overcome that, because for automation they need microseconds. So we chose that area. So in a simple problem, I think that was announced, simple but representative problem, like traveling salesman. So we like to introduce like 10,000x speed up on that. So that's the envelope we are going, like not twice, 3 times, 1,000 or 10,000 times more. So then it gets interesting.
Yeah,
Then supervised learning, unsupervised learning, and then the learning happens in a meaningful way. Yep. One last question, or second to last? No? So thank you for your attendance, and thank you for your time here. And so you can catch me and my colleagues throughout the conference. We have few colleagues from Fujitsu. Maybe we can call them out. And here is the head of our anomaly detection technologies and software technologies. And Ueke-san, you want to introduce yourself? He is the master of software on chip, doing things on the hardware that people are used to doing in the, like doing data compression and encryption on the hardware, and he goes much deeper than that. So one of our hardware group's superstars. Anybody else? Am I missing from Fujitsu? Not yet. Yeah, and also this voice you heard on the video, Steve. I'd like to thank him too. That's the voice behind the. He is voiceover, but he's more than that, CTO of Systriim. Please. Yeah. Oh, there is a lot in the news on quantum computing, so it's coming to. The question is, so quantum computing, yes, and in this. We'd like to also push the classic silicon as far as possible. So we have technologies in that area to cover the gap. So the quantum computing will come with how many qubits available for commercial problems? Yeah, it's a, well, cooling, that's the part. Yeah, 5 Kelvin is in scale. With hundreds of qubits. So it's an area, but we are working with the quantum computing software partners again, so that they can actually not simulation or emulation, but they can do those optimization algorithms. They can do it now on a commercially available platform today. Not more than simulate, to do things in production till quantum computing becomes a reality. So, and then we are hearing very good feedback on that. So the quantum computing, yes, brain computing behind that. So we will all be connected to some big collective maybe. Yeah, so there is still a huge gap we like to fill to the quantum computing. Yeah.
Maybe not exactly related question.
Please.
Since this topic or point came up several times, high performance versus
Power.
low power.
Yeah.
Is there enough data? Just looking at the future, one can imagine that at some point the amount of energy consumed by the computing devices may get on par with the amount of energy consumed by producing devices.
Yeah.
So, is there any data showing this trend? And, you know what I mean? Like our control devices
Yeah.
on a given factory will consume more energy than the actual motors that rotate something, do some
Yeah.
production.
So right now we are living that with the general purpose, traditional architectures, we are living that. Yeah, as we try to, and then, so we have some technology advancements over there, but the envelope is solid. Yeah, you do reality check, yeah, this is this much you can, with this architecture you can go only this far. So we have those limits.
Look at a modern,
Yeah.
computer room with the racks and stuff.
Yeah.
And it requires,
Yeah.
forced cooling, right?
Yeah,
That means that the amount of energy spent there is
there will be diminishing returns to say the least, or
right.
the
And
most kindly.
When it comes to quantum computing, probably the amount of energy spent there.
That too, no? All that cooling expense. I mean, in the traditional systems, yes, we are doing liquid cooling, and not only in the rack, but we can drop the whole boards into dielectric bath, and then at least increase the power ratio by factor of 2, 50% improvements and things like that. But there is a reality check, regardless. Yeah.
Don't you have any basic check for machine learning, like similar to like Google has taken Unity class?
Yeah, so that's our DLU, deep learning unit. That's yeah.
What's the size of that chip?
Like my palm. I touched it. Yeah.
But it's not a single chip, it's not
Inside are details, so we will reveal those, or I will learn those. I'm peeling the technology to get there.
So what do you think of persistent memory and how does it fit?
Excellent. Yeah, persistent memory. That's a new learning area for me, very humbly, if I may. So the memory architecture to be used for that, persistent memory and VRAM and other memory technologies, I haven't peeled it enough personally yet. So I'm just excited about the deep learning unit, but that's something we can discuss, or we'll discuss in the coming, as the technology comes to production gate a little bit further. Yeah. But thanks for the question. Yeah, exactly. Yeah.
Fujitsu did announce a RE-RAM last year, right around this time.
Yeah. Yeah.
Is that going to be part of that solution?
It could be. I should be political. So, not political, but yeah. So, we did announce it, but we didn't discuss the details of the AI architecture from that perspective. But thank you for pointing that out. Yeah.
So all this in-memory computing needs a lot of memory, and it's kind of expensive. The DRAM price goes up. So you guys you use any like memory compression or anything to sort of optimize the memory usage?
We do that continuously on the traditional architectures as well, for scaling the memory on one thing, and also to so persistent memory is another direction, but enterprise features or like memory failures. I mean, if you have like 10,000 DIMMs and one of them is going to get fried some of the time, at least, yeah, continuously. That's our like the strength area. So even with the off-the-shelf DIMMs and memory, we do that enhancements to our system bus, our system architecture to enable those scalability, reliability, and other aspects.
So that is done by software, or do you have hardware for using memory?
Yeah, for us it's the blurry distinction because we do implement things in the hardware, but we do work with software too. So if it is worth it, so we have our superstars implementing in the hardware as an instruction or as a capability or an error check or something of that sort. Yes and yes.
So do you see an explosion of the memory, the demand on the memory
Now let's put it that way. I don't think the memory requirements will go down because the data is exploding. So, so the trend is not going to come down. The frequency of data collection is increasing. I mean, this morning I'm listening to Steve from Systriim. Yeah, try to extract the information in the data and then try to keep up with it, you know. You don't have the luxury of discarding or top filtering the data anymore. Like the sensor is pumping data 100 times a second. So in the firmware, people reduce it, okay, 1 data point per second. But then there is a lot of information in the part that you just deleted or removed or washed away or bleached. So yeah, there is an explosion. You are trying to keep up with it. There is no white noise anymore. White noise is opportunity for doing AI or the deep learning from the white noise. Yeah, nothing is washed away. Thank you, and let's give some time to the next speaker too. I think already it was